Welcome to A-Star Science, part of our GCSE Must Know Physics series. Today we're going to be talking about radioactivity and half-life, a topic that you need to know for both your foundation as well as for higher tier GCSE exams. First, what is half-life? Well, there's a few different definitions you can use. Half-life is the time it takes for a radioactive nuclei. So the nuclei is the nucleus to decay in mass by half. The definition I like to use is the time it takes for the count rate to decrease by half. So when we say count rate, if we imagine that we had a radioactive nuclei and that was emitting alpha particles, beta particles, and gamma rays as pure energy, this emission would cause this nuclei to decay in mass because mass has to be converted into energy, or it can be it can be transferred as mass itself. The alpha particle has a mass of 4. The beta particle does have a small mass because it's equal to an electron, but the gamma ray doesn't have any mass, but it requires mass to be converted into energy. So you can measure this emission of mass and look at what the half-life is in this regard. Now in GCSE, they'll give you this question in 2 ways. They can give it to you as a graph, like what we're going to look at now, or they can give it to you in a word problem. Let's first look at a graph problem, how to determine the half-life. Now this is quite simple. If we look at the count rate, which means the amount of radioactive emissions over a period of time, in this case it's counts per minute. Here they're emitting 800 counts per minute. So to find the half-life, we simply look at half of this total count, which would be here 400. Half of 800 is 400. Then we move over to the line and then look at the time it takes for that half of a count to happen, and that would be 100. We could check that again. Half of 400 is now 200, and we can see that matches up again with 200. And so here's another 100 days. So the half-life in this case is 100 days. It is the time it takes for the count rate to half. So that's how you do half-life. Let's look at another example, which involves a word problem. So let's look at a word problem-based question on half-life. So if we look at the question here, it says find out how many half-life it takes for the count rate to fall to 50 counts per minute. While here, if we look, the starting half-life is 80 counts per minute. 800 counts per minute. So if we want to find out how much it takes to get to 50, we simply start to half it. So 800 half is 400. 400 halved is 200. 200 half is 100. 100 then finally becomes 50. So how many half-lives? 1 half-life, 2 half-lives, 3, 4. That's going to be 4 half-lives. The second question says, how long does it take for the count rates to fall to 50 counts per minute? Well, it says each half-life takes 30 minutes. So if we know that each half-life is 30 minutes, we multiply that by 4. And so that's simply going to be 2 hours. 2 hours. Good. And then finally, it says what mass of the radioactive isotope remains at this time. Well, we started off here with 64 grams. We just need to do 4 half-lives. So 64 grams will become 32 grams. That's 1 half-life. 32 will become 16 grams. That's 2 half-lives. That becomes 8 grams. That's 3 half-lives. And then that becomes 4 grams. So you can see we did 1, 2, 3, 4. 4 grams will be remaining after these 4 half-lives. So radioactivity and half-life questions are not very difficult. You just have to be prepared to do the graphical based questions as well as the word problem questions. Please like and subscribe. Let me know if there's any topics you would like me to cover for your GCSE science exams.